With due respect to our teacher, Dr. Saurabh Chakraborty, I, Shampriti Adhikari, I am going to elaborate the CA1 on the topic classifications of signals. So, at first, we need to know what a signal is. A signal is a representation of different types of information that may change with time, with space, or any independent variable. And it can be used for transmission, for storing anything, or for processing. So, we can divide signal in several classes depending on different characteristics and function. For time, we can divide it into two types. One is continuous time signal and another one is discrete time signal. For the factor determinism, we can divide it into two types. One is deterministic signal and another one is random signal. In case of periodicity, we can also divide it in two types. One is periodic and another one is periodic. In case of symmetry, it's also two types. One is symmetric or even signal and another one is non-symmetric or odd signal. And the last one is power content. In basis of power content, we can classify signals into two types. One is energy signals and another one is power signals. So now I'm going to discuss about continuous time signal. So a continuous time signal defined for every value of time within a range which is represented by continuous function. We can represent continuous function by xt where t can take any real value. Example is voltage of a circuit, a sine wave or a cosine wave, etc. There is some characteristics of continuous time signals. It defined for all real values of time. The signal is uninterrupted. There is no interruption in this signal. And last one, it can take continuous amplitude values. Here is a graph for continuous time signal where we can calculate xt for every time value. Now I'm going to talk about next one, discrete type signal. So discrete time signal is defined only at specific point in time, which represented by sequence of values. Actually, they are represented by a sequence of value, which is xn, where n is an integer. It can be a number or anything, but it is an integer. Uh, the examples of these signals are stock prices, which is recorded at the end of the each trading day, etc. Characteristics are we can define only at discrete instance of time, and we can have continuous or discrete both type of amplitude in this type of signal. And last one, we can often short it. It can offer shorted or processed digitally. Here is also a graph of discrete time signal. We can see. So the next one is determinism. We can divide signals in basis of determinism in two types. One is deterministic signal and another one is random signal. So what a deterministic signal is? A deterministic signal can be exactly described by a mathematical equation, and it can be aperiodic and it can be periodic both. We will discuss about periodic and aperiodic in the next slide. So it always described by mathematical equation. There is an example of this signal which is xt is equals to 5 cos into 3 pi 45 t plus pi by 4. It always predictable for any t. So there is a graph for deterministic signal, and the next one is random signal. A random signal cannot be exactly predicted before it occurs. We can find it after its occurrence. So here the signal is random and it often changes in an irregular, non-repeating manner. There is a graph of random signal. where the signals are random. They are not described by a mathematical equation. They are randomly selected. So next one is periodicity. We can divide it into two signals. One is periodic and another one is aperiodic. So a periodic signal repeats itself exactly after a fixed interval of time is called a periodic signal. So we can the periodic signal repeats itself after a certain time, and mathematically we can say xt is equals to x into t plus capital T for all t, where capital T is time period, and for discrete time signal it is xn is equal to x into n plus capital N, where n is integer. There is a graph for periodic signal where we can see the graphs are repeated in a certain time in a certain time interval, uh, and this graph will be repeated after a certain time. Next one is aperiodic signal. This type of signal do not satisfy the periodicity condition, so they are called aperiodic. This signal do not repeat over time. It never repeats over time. It don't have a fixed cycle, and it can be infinite duration or finite duration. So it's an aperiodic signal. We can see in this graph. So next one is symmetry. We can divide it in two types. One is symmetric or even signal, and another one is non-symmetric or odd signal. So we will discuss about symmetric or even signal. A signal is even if it is symmetric about the vertical axis. If we cut graph in vertically, then if we get same mirror image in both sides, then we can call it a symmetry or an even signal. So mathematically we can write x into t is equals to x of minus t for all t, and for discrete domain it is x into n is equals to x into minus of n for all n. Here n is integer number. Here we can see mirror symmetrically at t is equals to 0 or n is equals to 0. Energy is equally distributed on both sides of the axis. So there is an example of symmetric signal. It is a cosine graph. It is a mirror symmetric at t is equals to 0 and n is equals to 0. Next one is non-symmetric or odd signal. A signal is odd if it is antisymmetric about the vertical axis. So if we cut graph into two sides, then we do not get mirror image. It is a negative mirror image. So um, for continuous signal it is x into t is equals to minus of x into minus of t for all t, and for x into n is equals to minus of x into minus of n for all n, where n is an integer number. If we know xt and x into minus t, then x odd t is equals to xt minus x into minus t divided by 2. The left half is the negative mirror image of the right half. And the example of this is sine graph. We can see the graph here in this slide. So the last one is energy and power signal. So what a power signal is? A power signal is a signal if its average power is finite and non-zero. If the power is p, then we can write p is equals to limit t tends to infinity into 1 by 2t integration of x into t whole square dt. And in case of discrete domain, we can write p is equals to limit n tends to infinity 1 by 2n plus 1 summation of mod x into n whole square. there is a graph for power signal, and the next one is energy signal. A signal, a signal is an energy signal if its total energy is finite and power is zero. The energy E of signal is xt for continuous time or xn for discrete time, is defined as E is equals to integration of mod x into t whole square dt for continuous time, and for discrete domain it's E is equals to summation of minus infinity limit to plus infinity summation of x of n whole square for discrete time. There is also a graph for energy signal. In this graph we can see it is decreasing exponential function, and there is also a type which is neither energy and nor power signal. This type of signals have infinite energy and zero average power. Example is linearly increasing ramp signal. So here is the whole classification of signals. So here I end my presentation. Thank you so much.